Hello guys, I hope all of you are doing great. We are team 5. I am Suvarchala and my other two team members Anik and Minakshi. Today we are here to present our project that is Generalized Data Generator for Big Data Systems. So to start off with, I will go through some slides which have the definition of big data, some use cases, and then we will slowly move into big data testing. We will now look at few. So big data can be defined as the data which is generated and is arriving in increasing volumes from different sources and in different forms. So this data is of a huge volume as well as a variety. So the data is generated from millions of people through their devices or organizations, machines, and etc. So the data can be classified into three. So first one is the structured data, second one is the semi-structured data, while the third one is the unstructured data. So structured data is the one where data can be in the form of tables and columns that are of specific data types. So when you consider some databases like Oracle or SQL, so that is the structured data that is available in the form of tables. Moving on to what is semi-structured data. So the data in the format of an XML, JSON file, or a CSV is the semi-structured data. Unstructured data is a data which is in the form of images or text or video. So it is a combination of all such files. So few examples of unstructured data could be surveillance videos, the biological records, research and military-related data, roadmaps, so on and so forth. We will now look at few use cases of big data. So the race for customers is always on in businesses. So big data provides retailers with a clear view of customer experience so that they can fine tune their operations. As well, it can be used in machine learning. So we are now able to teach machines instead of program them. So the availability of big data to train such ML models makes that possible. Big data also provides some insights regarding the customer behaviors, the spending patterns, so that when a customer appears to leave, so customer service can work more proactively to retain him. So these are few use cases that we have seen. Now we will move on to moving on to the question of why not traditional databases like the Oracle or SQL. So Oracle and SQL are some examples of databases where the main intention is to store structured data. That means the data can be put up in the form of tables with columns of some specific data types, and if when you want to retrieve some particular kind of data, there is a key or a unique identifier with which you can communicate with with all of the tables in the schema structure. And the second reason is traditional databases are not designed to handle the velocity of which the big data is being stored or retrieved. So these are the two primary reasons why we are not able to use traditional databases. Moving on to big data testing. So as we know, testing means verification and validation of data. And in the case of big data testing, so to test the big data application, we need to ensure that all the functionalities of the application are working as expected. And the major goal of big data testing is to make sure that the system runs smoothly and error free while maintaining the performance and security. So while we talk about testing, the thing that comes to mind is how the test data is provided or where does it come from. So usually to define what a test data is, it is a data which is required in executing the test cases properly and to verify the expected output of the system under test. So next we will move on to why test data cannot be entered manually. We can never build upon the volume and variety of data. That is one reason, primary reason. While the second reason is we can always bias test data to our own usage patterns and miss out really on the important data that can be decisive. So these are the two major reasons why we do not go for manual test data. And most important factor is the speed that matters. So manually you definitely cannot match up the speed to the automatic test generation that happens. And the main challenge is definitely to produce a test data that is similar to the production data. So keeping all in mind, so we will move forth to what a test data generator is. So to talk about test So to talk about test data generator, I'd like to go through the life cycle of it, which is in 3 phases mostly. So first one is the control flow graph creation, which consists of the representation of the transfer of control. And second is the path selection phase, where the path of the program, especially the control flow, is identified. And third phase is the test generation step, where a set of realistic input data is generated from a selected path. So our idea to work on the automated test generator was because there are a few tools that are available, like the BitTag or GenTest tools, which were meant to test data, and we were curious enough to have a hands-on those tools and know about what is the kind of test data that is being generated. But due to the unavailability, it was not a successful attempt. So we had this idea to implement our own test generator. Our idea is to implement the existing library to develop a generator tool that provides data which is of scalable volume and appreciable variety. So we have implemented a custom model which is specific to the entertainment domain and which is open source. To give a little background of what we are using, so the data generator usually generates a pattern using 2 pieces of information from the user. So one is the SCXML chart, which represents interaction between different states and setting values of output variables. So this is basically a control flow language which is powerful and application independent, and it is a platform to customize. It has a platform to customize the language too. And the second phase of the data generator is a user transformer, which formats the variables and stores them. Little idea about what is the related work that is there in this field. So there's one paper by Mr. Liu which proposes a testing technique that is mainly focused on performance in terms of response time, while regarding the other related works in this area and the other part of topic where we speak more about the logic, it is taken over by my other friends here. So I'd like to hand it over to Meenakshi, please.
Hi guys, I am Meenakshi. I am going to explain about the relatable works. The protecting and minimizing database for software testing task uses a weight-based data clustering algorithm which partitions data in the databases and use that information obtained using program analysis that describes how this data should be used by the application. For each cluster, a centroid object is computed which represent the different entities in the cluster, and a representative record for each group based on the notion of centroid object. They are performing static analysis to determine the weights of the attributes, which is needed to compute the distance between different records. By doing this method, the centroid object replaces the original dataset. The other tool they are using is MyWrite. The advantage in this tool is without imposing any restrictions on the data modeling language. This tool generates data by using rich data generator programs that can be executed in the parallel manner. linearly in a shared nothing environment. The parallel execution scheme implemented by MyRate tool relies on a pseudo-random number generator that supports random access of the produced random sequence. It allows distribution of the generation process across many nodes and ensures that they run completely independent from each other. The next tool is BitTag. They uses combinatorial test data generation approach. In that they create input domain models automatically by analyzing the original data source and then added constraints by the man derived from the requirements. Each column of a database is taken as an input parameter. So for each parameter, important test values are derived from the constraints. If there is a change in the source, there is no need to create the input domain model from scratch. What it does is it creates another input domain model named adaptive input domain model, which is updated by comparing the changes against the additional information and then used to generate new data sets. Architecture of BitTag tool. BitTag consists of two phases, the initial phase and the subsequent cycles. In initial cycle, BitTag collects and analyzes the original data from the source and the constraints. BitTag saves the analytical results and derives important values to create input domain model for each input. It creates adaptive input domain model by combining the input domain models with analytical results. And effective test generation is created from the adaptive input domain models. In the subsequent cycles, there are three types of changes will happen. The first one, new data coming from the customers, and the second would be the existing constraints are modified or if new constraints are added. Third, the reviews return feedback from the generated datasets, previous datasets, or from the analysts, developers, or testers. Then the constraints are updated based on the feedback. So if there is a data or constraint changes, it collects and analyzes the changes and update the existing adaptive input domain models so that effective test data will be created and it can be used for the testing purposes, but it's independent from the created data sets. The following slides will be explained by my teammate Nick.
My name is Nick, and I'll be discussing the open source data generator library. We talk about how we were able to use it, how it works, and what goes on under the hood to allow it to generate data. So as was mentioned previously, when we reviewed the literature about big data testing and big data generation, we kept finding that the tools that were used by authors were not accessible. When we tried to replicate what they did, we were unable to find their tools. So because of this, we started exploring open source tools that would be able to solve the current requirements for test data generation. And we came across this data generator library, and it's open source and seemed capable of meeting the requirements. And we chose it because of that and because it took an interesting approach to data modeling. So to use data generator, you first have to model your data in state chart XML or SC-XML. This is an XML-based language that is able to completely describe finite state machines. And the example on this slide shows how the 8 lonely rooks problem can be solved with data generator by just creating an XML model, or SC-XML model. And for those who don't know, the 8 lonely rooks problem asks how many ways can 8 rooks be placed on a chessboard without them being able to attack one another. So if we take a look at this model, The first state, Rook 1, will assign Rook 1's rank to 1. And then it will assign Rook 1's file to one of the 8 files in this set. So either A, B, C, D, E, F, G, or H. This state will then unconditionally transition to the Rook 2 state, where Rook 2's rank is assigned to 2, and then its file is again assigned to one of the 8 characters from that same set. Now the difference is this state will only transition if Rook 2 and Rook 1 are not assigned to the same file. And then this pattern will continue for the remaining 6 rooks, where the transition will only occur if the rook that's being assigned is assigned to a unique file. So when this model is processed, all possible combinations of values from the sets will be explored, but only the combinations that make it through all transition will be output. So when this SCXML file is passed to the data generator, the output will be all the solutions to the 8 lonely rooks problem. So this slide gives an overview of what's going on under the hood when the data generator library is running. The first thing that happens is an SCXML engine will initially search the SCXML model and determine every single variable that would be associated with one data point. It will then create a default map for this data point with each of the variables initially assigned to just an empty string. Next, the engine will start a breadth-first search on the model up to a user-specified depth, which is shown in the diagram just where the red line is. So in this example, the specified depth was just 1. And then once this depth is reached, a data generator distributor will serialize each of the unexpanded children that are in the fringe of this graph, and then send them to separate threads or separate compute nodes to be processed by a data generator consumer. Each consumer will continue searching the model with a depth-first search until all variables have been assigned. And then once all of these variables have their assignments, the data consumer will send the assignments to the data writer for output. So now I'll talk about the steps that we took to use Data Generator to generate some test data. In our example, we were modeling data that might be used by a streaming service. So the variables in this model are title, type, category, duration, rating, and the date added. So in this slide on the right, we have the SCXML that we made for this model. And the first thing that happens is the title is assigned to a value from the titles.txt file. This file contains around 1,900 movie names, so then when the data is being generated, each one of these movie names will be used just one time to create one data point. The next step is to assign the type variable, which is assigned to the value @type, and then immediately after the DG transform is invoked, calling the transform that we map to SWE transform. This transform is used by the SCXML engine, like during the breadth-first search, to transform variables. The simple transform that we've created is shown here on the left. And it will randomly assign the value of either movie or TV show to the type variable. And the next thing that happens is, if you follow the model, we will transition to another state depending upon the value assigned by the transformation. So the next two states, both movie and TV, are actually in parallel and are mutually exclusive. So both of these states will assign values to the duration and the rating variable. They will either get a TV duration and a TV rating, or a movie duration and a movie rating. These assignments will then be transformed later on in the data consumer process, which will be talked about in the next slide. Both of these states will then unconditionally transition to the final state to have the category and date added variables assigned. And now this slide shows the transformer that is used by the data consumer. And this happens after all the variables have had their values assigned. So this happens after the depth first search is completed, but before this data is sent to the data writer. The right shows the simple transform that we wrote. So this will just simply check for a value that has been prepended with the pound sign, and then it will call the appropriate function that's associated with that value. And the methods that we have shown here are for get TV duration and get movie duration. And they will randomly select values from a range to assign to the variables. So under normal conditions, TV duration will assign either 1 to 10 seasons, and then movie duration will assign 72 to 184 minutes. But the final thing we wanted to do with these transformations and with our data in general was to show how common types of errors could be introduced to this generated data. So to make this data more realistic, or have more realistic errors in it, we decided to give it different types of formatting. So normally the TV duration would always be generated in the units of seasons, and the movie duration would always be generated in the units of minutes. So if we turn on our malformer, for lack of a better word, the TV duration might be generated in units of episodes instead. Well, and then the movie duration might be generated in units of hours plus minutes instead of just minutes. Using a transform function like this will allow the insertion of inconsistent and more realistic type of errors, but in a controllable fashion.
Validation allows the user to check that the data generated is complete and they are valid. It also ensures that the data used for testing are accurate, qualitative, and are in same format. It helps to maintain data integrity because it helps to ensure the legitimacy of conclusions. Some common data validation rules that helps maintain integrity are data type, to check if the columns are of same data type, and of data range, and if unique values are in some columns, and there will be no null values. We are using Python to the validation of data generation. The validation step which we follow are, first one is to check for the null values, and the next step is to remove leading and trailing space, because it plays an important role in security. In case if you take string literals of many lines, the trailing white space can make the output string looks different and incorrect when it is used. The third validation step we used is to check for the duplicate values. If it's that, we have to remove it, because testing the data with the duplicate value will affect the results and the quality of the testing. The next validation step is formatting the column. If the data all are of in same format, then it helps to maintain the consistency of the data, and it will be also helpful in the data processing step too. For example, in case if we take a date column, it would be always of different format, so it will be very difficult in the processing steps. Our next step is checking data range. It will check the data type of the input and the range of the input. For example, the movie rating column value should be from 1 to 5. If it's any other numerical value, then it would be incorrect value. Conclusion. Big data applications are designed to handle a very large volume of data. To test these large data sets must be created with enough varied data to cover as many scenarios as possible. So if we create manually these large data sets, it is not feasible. So in our project, we use an open source and readily available tool to largely automate the data generation process. By creating an SC XML data model and defining a handful of Java functions for data transformer and large amount of varied data, we are able to generate it quickly and easily. We also use the technique to inject common errors into the data set were also described, and these malformed data sets would be useful to test how a system will react when we give a malformed data or unexpected data. We also shown how testing big data applications can be facilitated by generating millions of data points in a few seconds by using open source and readily available data generator. Thank you.